Okay, so here we are in 3.6, and I'm going to do just a couple of examples here. So I've got number 11, and we're doing derivatives of trig functions, right? So tangent, secant, and it actually gives you the derivatives here, right? So I'm going to go over, so you've got the derivatives there on the page, right? So we got the derivative of sine, cosine, and this is really all you need. The derivative of sine of x is cosine of x, and you can use these as it does here in the above this, is it shows you how you get from tangent to secant squared, right? It's just tangent is sine over cosine. Go ahead, do the quotient rule, which is sine over cosine, so f over g. It's f prime g minus g prime f over g squared, right? And the product rule here is going to be f prime g plus g prime f, right? Now I know in the book they do this backwards, but it doesn't matter. I like this way because it allows you, so this is the product rule. The quotient rule is just a minus right there, right? That's very strange. Okay. Okay, so I was charging it, but it says it's too hot. So maybe if I uncharge it, unplug the charging. Okay, so what I'm going to do is I'm going to take f and g. So I've already written it out. Let f be this, g be this. And over here, I've got the product rule. And so f prime, so f prime, f is tangent. And so f prime is secant squared, and g prime of secant is secant tangent. And this is over theta, obviously, right? And so this is going to be f prime, which is secant squared. It's going to be secant squared theta times g, plus g prime, which is secant tangent times tangent. Okay, so I'm going to get secant cubed theta plus secant theta tangent squared theta, right? And if I pull out a secant, I'm going to get secant theta times secant squared theta plus tangent squared theta. And if we remember our trig, it is, yeah, I don't think there's any simplification of that, right? So we can go back to trig and see, can we simplify? Well, secant squared is what? I think it's 1 plus tangent squared, right? So you could take this into 1 plus 2 tangent squared theta, if that was it, right? And then you could multiply secant plus, you get secant, secant plus 2 secant theta tangent theta. So I think this is just it, right? You could just leave it as one of these ways. Okay. So either one. Okay. Okay. How about number 21? Is sine x plus 1 over sine x minus 1. Okay, so I'm going to call that f and that g, right? So f prime is equal to, well, it's going to be the derivative of sine x plus the derivative of a constant is 0. So in both cases, I just ignore that for a moment. So the derivative of sine is cosine. So this is going to be f prime is going to be cosine x, just simple as that, and g prime is also cosine x. And so here I'm going to have the derivative, I'm going to have f prime, so remember the quotient rule is f prime g minus g prime f over g squared. And so I'm going to have I'm going to have g squared sine of x plus, minus 1 quantity squared, that's g squared. And then in the numerator, I'm going to have f prime times g. So I'm going to have cosine x times sine x minus 1. and that's going to be minus cosine x times sine x plus 1. Huh? Okay, can we simplify this? Well, it's fine. I'm going to get cosine x sine x minus cosine x. So I'm going to get cosine x cosine x sine x minus cosine x. And that's going to be minus cosine x sine x. And then minus cosine x. Okay, so cosine x sine x, they're going to cancel. And I'm going to get minus 2 cosine x over x minus 1 squared, which cannot be simplified, right? So I'm going to get minus 2x over minus 1 quantity squared. Right. Okay. And I think that's it. Yeah. Very good. Right? Okay. All right, what else do we have? Let's come back to number 24 here. So number 24 is cotangent over 3 minus 3 sine z. Okay, so again, I'm going to go and I'm going to look at these to find out what f prime and g prime, right? So again, f prime, so this is f, there's g, and it's going to be f prime g minus g prime f over g squared. So f prime is, what's the derivative of cotangent? Well, that's negative cosecant squared. So that's going to be negative secant squared z times g, which is 3 minus 3 sine z, minus cotangent z times the derivative of this, which is going to be, what's the derivative of sine? So this is just going to be negative 3 times the derivative of sine, which is cosine. So it's going to be negative 3 cosine z. And that's going to be over this thing squared. Okay, so now let's simplify. I'm going to get negative 3csc squared z minus 3 is going to be cosecant times, well, cosecant is 1 over sine, right? So this is going to be sine over sine squared, which is going to be 1. So minus 3 cscz, right? So again, this is sine over 1. This is 1 over sine squared. So sine is going to knock out one of those, and it's going to be minus minus is a plus. And then minus cotangent, remember tangent and cotangent, this is cosine over sine, right? So this is going to be plus 3, and then cosine squared over sine. So let's, let's write that as, well, this is cotangent times cosecant, so it's going to be plus 3, and I'm going to have cosine over sine times cosine. So actually you could write this as, this is cosine squared cosecant, scz times cosine squared z, right? It's all going to be over that, equals, and then I'm going to pull a cosecant out just because I can actually pull a 3 cosecant. So let's pull a negative 3, why not? Secant z, and I'm left with just a, I'm just pulling that cosecant z out of there, and I'm left with, I'm left with a positive 1 cosecant z, and then it's going to be minus, the 3 is gone, one of the cosecant is gone, and I'm left with minus 3 is gone, the cosecant's gone, and I'm left with the cosine squared z. And that is going to be over, and if I, I mean, I could pull a 3 and I could go ahead and multiply this all out, pull a 3. Yeah, so this cosecant can actually go into the denominator here if you want, so I can make that a negative 3 minus 1 minus cosine squared z, and in the denominator this 1 over sine would actually put a sign down here, and it would be sine of 3 minus 3 sine z squared. And then if you wanted, you could go ahead and multiply this out, simplify it, right, which I would probably do, and you know, this 3 would cancel out. This would be 9 minus 6, 18 actually. Be 9, 3, it'd be 9 minus 18 sine z squared z, or sine z, and then plus 9 sine squared z. And yeah, so you could simplify it from there, probably get rid of the 3 up there, and I don't think you could really do a whole lot with it. It wouldn't look a whole lot prettier, but there you go. All right, this is the derivative of that, right? Okay, more to come.